Good morning, everyone. Welcome aboard again, hopefully for the 6th webinar on steel wire rope. Today we do all the basics, all the webinars we did before, all the topics. My name is Michel de Vos. I'm from Menens, and our expert on steel wire rope, hopefully you know him again, will do the presentation today, which will take around 45 minutes. I need to do this. Welcome again. There are some house rules. Your mic is on mute. If you have a question, please type in the chat. After this session, the last 10 minutes, we'll do the Q&A. Of course, we will record this session. So afterwards, you will receive the email with the record and, of course, with the presentation of Alain. And last point is enjoy. Some practical parts, if you not know us, well, we're the global partner in Lifting Solutions. We're part of Axel Johnson International, a Swedish company. And within Lifting Solutions, we're the experts in lifting equipment, steel wire rope, fall protection, of course, services. A full solution provider, so not only delivering products, but also doing inspection, maintenance, repair, etc. And of course, we will show that in the next slide. We have a local presence in every country, 90 countries. We have that. I need to list this. I think you know this. These are the same numbers, but you see our coverage worldwide in the red part. And the last part is, as I said before, a group of companies operating local, and I think one of the logos is familiar to you. I now hand over the presentation to Alain, and hopefully you will enjoy this webinar.
Well, good morning from me. I'm Alain Bouwman. I'm at Menens, Belgium, since 1986, so let's say I'm a senior wire rope specialist. Wait and see. I give advice to people for their installations. We do a lot of investigations. We make service life reports, and we have our own lab to check out why things are working so good or not working so good. So my name, Alain. You can call me, or if you have questions, you just put it later on. Okay, what are we going to do today? We're going to have 5 highlights, let's say. Steel wire rope, what is it? How is it made? Standard constructions. In the second chapter, I'm going to tell you something about high performance wire ropes. What's the difference? We're going to do some discard and how you put your ropes out of service. A fourth chapter is maintenance of your ropes, like lubrication. And then we end up with fittings on ropes with end terminations. So good luck. Keep tuned. First, steel wire rope. What is it? How? And I'll give you some standard constructions. Well, let's say that what do we need to have a good wire rope? It has to sustain for high temperatures. Sometimes it is in acid environment. We need to take care of corrosion. Ropes must sustain high pressure. There's sometimes rough treatment, high speeds, shocks, many times bending over sheaves and drums. And sometimes you need a certain safety factor depending on the applications. You need a rope which is flexible. Then we can choose a 6-strand rope, 8-strand, or some kind of flexibility of the core. Ropes must sustain abrasion, crushing. We need a certain fatigue resistance. Some ropes must be rotation resistant or sustain some fleet angles, non-rotating ropes, and so on. So let's start with the basic material of making a rope, and that's the wire. You can start with bright wires, that means ungalvanized wires, or galvanized wires. In 80% nowadays we use zinc coated and drawn wires, or we can start with stainless steel wire. Now listen, we're not going to talk about stainless steel wire today because this is a different kind of rope. And we could organize a separate webinar for it, because stainless steel wires are going to have 25% less strength. It's going to be 7 times more expensive, and there are going to be a limited number of constructions. So stainless steel wire is only for applications where you have very high temperatures. You're going to use it on your yacht, or you're going to use it in architectural projects. Or if you need, you can make slings out of it, but you're never going to find it, or almost not, for hoisting. These are the different tensile strengths you can make your rope with. It's 1560, 1770, 1960 Newton per millimeter square, or 2160 Newton, the strongest today, let's say. These are the tensile strengths. That means that the prices go up, like you see the tensile strength. The hardness also goes up, so be careful with 2160. You're going to end up with a rope which is very strong, but also very hard. So you're going to need sheaves or drums which are hardened till a certain amount. Okay. For all these wires, you need to follow the norm, the regulations, the strength, the diameter, the minimum bending cycles, and so on. So normally this is done in labs for the people who make the wire. A little bit of wire rope terminology. You see, this is, let's say, how it looks when you cut a rope. You have certain strands, 6 or 8 or more strands around the core. So you have the rope, then you have the wire, you have the strands, and in the strands you have a center wire, which is in the middle, and you have inner wires, which surround the center wire, and at the outside you have the outer wire, which makes up, let's say, an idea how thick this wire will be. If it is, let's say, a thicker wire, you're going to end up with a rope which can withstand wear. But the flexibility will be less, okay? And you see that sometimes you have a core which is a fiber core, or let's say cordage inside, or you have an inner wire rope core, which is a separate rope as inner core, yeah? Okay, how can we make steel wire rope? We make it in 2 steps. Step 1 is we're gonna manufacture the strands. So stranding some wires to get a strand, we're gonna see that in 30 seconds. And then if we all have certain amount of strands, we're gonna close all these strands in a cabling machine. So around a core, which can be a fiber core or an independent core or even another strand, okay? So first of all, we're going to manufacture strands. These are the traditional, let's say the old type of strands. The most simple strand you can make is you take 1 wire and you surround it by 6 other wires from the same diameter. So then you end up with 7 threads, 1 plus 6. If you need a strand which is more flexible, then you start with a smaller diameter. Yeah. So we have 1 surrounding by 6, surrounding by 12. And then you get a 19 strength. You can add more layers to have more flexible strands, like you can see there, 37, 61, and so on. The problem with this traditional strand is that if you look from layer to layer, you get crossovers. So you have internal crossings between the layers, and these are point-to-point contacts, and this give you an internal wear. Yeah, so you're going to have cracks in these wires. Every time you bend the strand, you're going to have wear in the point-to-point contacts. To avoid this, people invented the parallel constructions. In the parallel constructions, as you see there on the right, you see that every wire is supported by two wires that are underneath. So there are no crossovers, yeah. So every wire is embedded and supported by two others. It's a very flexible strand, and there will be no internal wear. How can we make these parallel strands? Well, you made it like Mr. Seal has invented them. And as you can see there, we start with one center wire, and we surround it by 9 little wires. Yeah. So, and then we end up with a seal layer, which has again thicker wires. So you see there the 19 seal construction, like Mr. Seal invented it. You have layers, let's say, from thinner and thicker wires, and you get a very flexible strand. There was a Mr. Warrington, and he invented the Warrington construction for your parallel strand. And there you see we have 1 + 6. And then in the outer layer, he put alternatively thinner and thicker wires in the outer. You can also make a filler construction. That means that you fill up the empty spaces between the different layers, and you make it up with some filler wires. You see there the thin wires, and you end up with a wire which is supported also by two layers, by two wires underneath. Yeah, and then you could also join the seal and the Warrington construction in one construction, what we called WS, Warrington seal. That means you have a Warrington layer and you seal it up with thicker wires on the outside like you do in the seal. And these are very important stranding constructions. Then we end up with 1 + 5, 5 thinner and 5 thicker wires and sealing with 10. Then you have the 26 Warrington seal, you have the 31 Warrington seal, and very important is the 1 + 7 alternative thick and thin 7 + 7, and then sealing with 14, then the 36 Warrington seal. You're going to end up with 36 Warrington seal in a lot of constructions we're going to see later on. So there's no wear inside, there are no crossovers, it's very flexible. You have a rather thick wire on the outside, so which give you, let's say, resistance against wear. And these kind of Warrington seal constructions are very common. Well, to have a little show now how ropes are really made, I have a little movie to see. Wait a minute, here it is. Let's go to the factory and then see how things work. Yeah, there it is. So we start with the wire. This is the wire. So all galvanized or ungalvanized. Normally, many people ask for galvanized. We put these kind of wire bobbins into a machine. So, and as I told you, some with thicker or thinner wires. And this is a stranding machine. Now we're going to make a strand. Look, there are a lot of wires going into the plot there. So making up a strand. Yeah. What we do also in the strand is we're gonna put grease in it. You see all these different wires laying in different layers. Yeah. There you see the grease coming into the strand. We order our ropes with grease in the strand. There comes the strand. Yeah. The much too heavy grease, we strip it. You see the grease is between the wires. This is for making the strand more flexible, let's say. Yeah, this is the strand. And if we have, let's say, 6 or more strands, then we're going to close it up on the closing machine. There you see the different strands coming all together around a steel core. Yeah, This is the pre-formation. The pre-formation, so that all these strands gonna be smoothly fixed around the core. There you see the core. And for some applications, we add, again, some grease. Yeah, and we end up with the rope. Depending on the application, we can also change the amount or the type of grease you want. That's how we make rope in all different diameters. Let's say from 4 millimeter till 120 or something. Yeah. Yeah, there's something going wrong now. Wait a minute. Where is the presentation? Yeah, okay. So you've seen the lubrication. Normally all ropes are lubricated in production, and the loop is between the wires in the strands and sometimes also between the strands. Why do we lubricate the rope from the manufacturer? Well, we need some lubrication for the flexible stranding. Yeah, if you don't put some grease or oil in the rope by stranding, then you're going to end up with some wires who are fatigued already. So it's going to be smoothly if the strand is greased to make the strand in the machine. Secondly, it is conservation for the time ropes will be stocked. Yeah, and thirdly, it's going to be the first lubrication during the period, first months or first years. It's going to be the original grease on your application. The grease will disappear in time, so we advise then to do some maintenance and put some new grease or oil to prevent corrosion and to lubricate the whole system again. And don't forget, if you lubricate your rope, you're also going to lubricate your sheaves and your drums. So this will avoid wear or let's say problems with grooves of sheaves and drums. If you lubricate again, you need to take account for 20 to 30% more of lifetime. So that is money, really. Yeah. So lubrication must be quick, easily, and we're going to see that in a upcoming chapter. So step 2 is the closing of the strands. You can close it up with 6 strands on the outside. You end up with 6 times 36 Warrington seal with an inner rope core. You see the rope core there is a independent core. It is made out of 7 times 7. Or you can end up with cordage with a fiber core. And that's a 6-stranded rope. If you want a rounder rope, a more flexible rope, more rope which is rounder in the end, you can cable up with 8 strands on the outside. And here you have 8 times 26, 8 times 31, 8 times 36. You see that the core then is a little bit complex. Yeah, you need to have a special core because you have to fill up a bigger space inside your 8 strand. It's much rounder, so you're going to end up with a very high resistance against fatigue, and you're going to have less wear in grooves and sheaves. So 8 strand ropes will do better in your application. That's to see where you can have more contact with sheaves and on your drum. Yeah. We also have 7, 9, and 10 strands wires. You see, then the core is becoming more complex, but you have a rounder rope, which will give you much more strength, flexibility, and longer lifetime. If you manufacture ropes with more than 10 strands, so 11 and so on, then you're going to end up with what we call non-rotating rows, because then the center of your rope, so the core, will be inverted. Yeah. So these are for applications where you have very high hoisting, like tower cranes, mobile cranes, or one-part hoisting. I come back on that later. So for certain applications, you have certain type of standard steel wiring ropes for winches, for overhead cranes, for container cranes. Normally it's 8 strand. You see also there in the middle elevator ropes. Normally it's 8 times 19 in seal with fiber core, which is standard in Belgium. But you can also have with steel core. For elevators, we need dual tensile. That means that we're going to use 2 different kinds of tensile strength, with on the outside wires, smooth wires in 50-60 or 70-70, and on the inner side we use the standard 90-60 Newton per millimeter square. That gives you a very soft rope, which do much better work on traction wheels. Yeah, and then on the right you have the rotation resistant, so with the core inverted for high hoisting. Good. Perhaps you heard, or perhaps you've seen, there are right-handed and left-handed ropes. What is it and why do we need that? Well, I show you the left-hand rope. Left-hand rope is the picture on the left. You see that the strands go to the left, upwards to the left. This is a left-handed rope. The other one is with the strands going up to the right. This is a right-handed rope. See right. But if you look close in the strand, the right-hand rope has in his strands wires which goes to the left. This is what we call ordinary lay. So you have ordinary lay also in the left-handed. You see in the left-handed rope, you look into the strand, then you see that the wires are going on the right. Yeah, and this is what we call right-handed ordinary lay, because there is a guy, Mr. Lang, he invented the Lang's lay. What is the Lang's lay? There you have also in the left and the right hand rope, you have the right hand rope, but you look into the strand, there the wires also go to the right. And this is what Mr. Lang invented. As you can see there, the wires on the outside have a bigger space in touch with the grooves from the sheaves and from the drums. So we have more contact, and normally this type of rope will last longer. Yeah. So also in the left-handed, you have left-hand Lang's lay with the wires in the strands also on the right. On the left. Yeah. Why do we need left and right-handed ropes? Well, because if you use a 6 or an 8 strand rope and you put a load on it, you have the helix, and this helix will give you a certain moment in your wire. To compensate this moment, there must be a left and a right-handed rope in your application, so that these moments will end up to 0 and that your load will stay stable. So as you can see there in bends or at overhead cranes, you have a left and a right-handed will be ended up as a moment of 0, and your load will stay stable. Yeah. You also need to have left and right-handed because your drums are also cut left or right-handed. So you need to have left and right-handed rope. You put left on right-handed drum and vice versa. Yeah? So that's why you need left and right-handed. If you want to measure a rope in diameter, you see how you do it. You have to take the biggest diameter on the outer strands. And normally you have to do it at 5% of the breaking load, but anyhow, you see that there are tolerances, and the most important tolerances is for diameters higher than 8 millimeter. It is -0 + 5. Years ago, it was -1 + 4, but anyhow, we at Mannes, we take care that it is -0 till +4. Yeah. If you measure ropes coming from Mannes, you see that our standard will be +3.5%. Yeah, okay. That's for the standard wires. We go up now to high performance wire rope. What are these ropes? These are ropes invented by some German manufacturers in the 1970s. What is it? Well, it is rope which will last longer on your installation because we have plastic infill between strands and core, and compacted strands, hammered strands, and double polyland strands. I'll explain one by one. What they invented is to avoid contact between your center core and the outer strands. They invented to put some plastic layer between. As you can see here, all the red in the design is plastic. So yeah, you have no internal wear between the core and the outer strands. So it keeps the grease, the original grease, it keeps it into the core. Yeah, it keeps water or dirt outside the rope. Yeah. So, and it gives an increasingly stability of the rope. It prevents for opening up if you have some angles which the rope has to sustain, and then your rope will close up again. So it's not easy to open it up. That's the plastic infill, very important. Yeah. A second high performance effect is the compacted strands. What we do is we take the normal strand, as you can see there with the round wires, and we gonna compact it. So it is driven through some sheaves and you end up with die-form wires at the outside. You see, so you don't have any more round wires at the outside. It is die-formed, so you have a lot of contact with sheaves and with drums. You have a higher breaking load because you have more steel in the given diameter, higher flexibility, lower stress, smoother wearing surface of rope, also between ropes on different layers. You have the advantage that if a wire breaks due to fatigue, that it will stay into the strand, it will not pop out. Yeah. And there is no nodding between ropes on multi-layer drums. So with compacted strands, you have a better rope, a stronger rope, and a rounder rope, which is very important. It gives you an idea about, let's say, double or triple lifetime for these kind of ropes. Yeah, and you never have to worry what's happening inside your core because it's all closed up. There is still grease in it. And you won't have contact between the different strands, outer strands and inner. For some applications, you can do also the rotary swage rope, which means that you take a whole rope and you compact the whole rope to end up, as you can see there in these examples, with a much rounder rope again. Much rounder, where you can have the advantage of spooling it on multi-layers, so ropes one and up another, and you have more contact between all these layers. So it's much more robust, it's much more stronger, and for certain applications you need this kind of rope. And then a fourth thing is the parallel 8 and 10 strands, double parallel. As we talked about the parallel construction in the strands, you know, where you don't have crossover between the wires, we can also create a parallel construction, not with wire, but also with strands. So here you can see that all the strands are supported by two underlayer strands so that you don't have contact again, crossovers in from layers in strands. Okay. What are the advantages of high performance ropes, which are now, let's say, about 65% of all ropes used in hoisting equipment? You have about 30% stronger rope. You increase the performance in cranes, a longer lifetime. You do more cycles. You can do more tons because you have 30% stronger rope. So perhaps you can diminish the diameter, yeah, in your application. You have more stable diameters because there will be less diameter reduction due to the high filling factors. That means less wear on ropes and less wear on sheaves and drums because you have lower contact pressures because the rope is rounder. It is more secure. There will be no opening up due to rotation. You can accomplish higher fleet angles. Yeah. There will allow more wire breaks before you have to discard your rope, and you never have to worry what's happening inside the rope because everything is protected by the plast layer inside the rope. Rotation resistant ropes, we also talk about what's a rotation resistant rope. There the core is inverted, and as you can see, there are a lot of different type of rotating resistant ropes with a certain number of outer strands and certain number of inner strands. Okay. Next chapter is inspection and discard. I will explain what you need to know about discard criteria. For some standards, you have to look into your norms for country by country. I'm going to talk about the rope category number, yeah, and what is it and how is it used, and also for the magnetic rope testing, which we can do for you also, or just explain it. Okay, the discard criteria, when do you have to declassify your ropes? You have to look for wire breaks. You have to look for reduction of diameter and wear, look for corrosion or for some deformation. The first criteria are wire breaks. You normally have to count the wire breaks you see on your rope, and you take the number of wire breaks over 6 times the diameter of your rope, and you take the number of wire breaks over 30 times the diameter of your rope. If you got this, then you have to know the rope category number. So every type of rope has a category number. If you don't know that, it is normally the number of wires in the outer strands, yeah? But normally if you have a certification of your wire rope, it's going to be mentioned on that certificate. If you know your rope category number or the number of wires in the outer strands, then you look to this table, yeah? For instance, this table gives you here on the left your rope category number or the number of wires. Let's say we are in category 09, like it is 6 times 36, that's 260, so 201 to 220, that's rope category number 09. Then you have here on the green in the table, there you have a section of rope working in steel sheaves. Yeah, it's only for steel sheaves. And then you have ordinary lay and lang lay. This specification is for ropes which are working on a single layer drum. Yeah. The other section there in blue is for sections of ropes pulling on a multi-layer drum. Yeah. So if we look now for our rope, which is perhaps in ordinary lay, you can see you have 9 broken wires on 6 times diameter, or you can have 18 broken wires or on 30 times the diameter. If you exceed this, then you have to discard your rope. Yeah. For non-rotating ropes, it is 2 and 4. The numbers are 2 and 4. And be careful because you have some footnotes. If you look at the footnotes, you can double this figure, so double up 9 or double up 18, if you have a mechanism with head classifications from M5 to M8. So normally for a lot of applications like overhead cranes and so on, you can double up these figures in the table. We have to take care about internal valley breaks because you have seen we can count the wire breaks. These are normal wire, but take care if you see some wire breaks who look like this. These are very long wires and you see the wire is cut underneath the strand. If you see that, then you have internal valley breaks, very dangerous, let's say. If you see two valley breaks like this, you have to discard your rope immediately, because if you are going to open up your rope, you're going to see a little spaghetti like this. So if you see two valley breaks, you discard the rope also immediately. Valley breaks look like this. Yeah, okay. If you want to look inside rope, yeah, you can do a magnetic testing. That's a magnetic rope testing. We have all these kind of devices to put on the rope, and you get a whole spectrum of wire breaks on the outside or on the inside. Yeah, you can do it, let's say, in certain intervals, or you can leave some applications on your rope during working and so on. Okay. Second criteria is the diameter reduction. You have wear on the outside. What you need is you put it into this formula. You have the reference diameter when the rope was new. You're going to have the diameter of the rope now, and you add up with the diameter of the nominal diameter. You end up in a certain percentage. You put it into this table, and you end up with a percentage which is 20, 40, 60, 80, or when you arrive at 100%, it's discard. You see in this table you have a single layer with fiber core, or parallel with steel core, or rotation resistant ropes. Yeah. Corrosion. Sometimes you could end up with steel wire ropes, which has to be discarded with corrosion, fretting corrosion, internal corrosion, or external corrosion. That normally only comes with ungalvanized ropes, or with ropes which are galvanized, but where the galvanization is gone to wear. And then you have some kind of deformations. If you see this, or bumps like this, or like this, or locally increasing diameter, baskets, bird cages, loops, flattened portions, damage to heat, or let's say to certain accidents that happen, then you need to discard your rope, of course, also. Yeah, you can end up with a certain amount of numbers, wire breaks, diameter decreases, external corrosion, and if you have 80% or more, you have to put your rope out of service. There are some criteria or discard criteria for elevator ropes. Yeah, there are other criteria for slings. Yeah, so you need to see for what application you need. Fourth chapter is maintenance and lubrication. Yeah, a steel wire rope, let's say, is a machine. Yeah, and you have, as I told you, seen the originally lubrication coming from the manufacturer. Yeah. Anyhow, this will disappear in service, so you have to normally give some new grease into this system of wires and strands. Sometimes you have external factors like rain, salt water, heat, temperatures, dust, and so on. And you also have the contact between sheaves and drums. So lubrication will give you the protection of wires and strands, and it will extend your service life. You're going to end up with at least 30% increase of your lifetime. For elevators, it's going to be 40 to 50%. So for some applications, please do 2 or more times extra lubrication, so you're going to have less wear in sheaves and drums also. How to apply: spraying, you can do dripping, swabbing, brushing, or you can do it with under high pressure lubricator. We have these systems, we sold this system, or we can do it for you to put really new grease, let's say, until into the core of your rope. How much do you need to grease or to oil? You need 1% for standard ropes, 1% of the rate, yeah, and for high performance, do about a 0.5% of the weight for plastic infill ropes, let's say. That's really some rope which could use some grease, let's say, yeah. Okay. We're going to end up with some fittings. End termination, because every rope needs fitting, let's say. These are the different kind of terminations you see on ropes. Let's say that we're gonna see the possibilities. We have, first of all, the swaged ferrule, the mechanical splice. You can make loop or a thimble in an eye. This is done by an aluminium telluride, which is pressed on a swaging machine, yeah. Dies and ferrule must match the diameter and also the type of rope. Here you see a table, so every kind of rope, every diameter has a certain number of ferrule you're gonna put on. You can use it till 110 degrees Celsius because, yeah, it's aluminium. The efficiency is 90%. And you see here under certain types of ferrules, which are conical, and what is also very important is that, as you can see there where the arrow is, that you need to have one side coming out of the ferrule to be sure that the rope is completely set through the ferrule. A second type of swaging is the Flemish eye. This is a super loop swaged eye with thimble. That's for 6 and 8 strand ropes. You're gonna split the rope in 2 parts. You're going to make a loop, yeah, and then you're going to seal it off with a conical steel ferrule, yeah. So it's swaged into a certain machine, and there the temperatures can go up till 150 degrees because it's a steel ferrule. And if you need more applications in higher temperatures, then you're going to see you're going to end up with 300 Celsius. It's going to diminish only 25% in strength. The whole efficiency is also 90%. So steel ferrule Flemish eye super loop swaged. Yeah? This kind of swaged forged terminals can also be swaged on the rope directly. It is not reusable. You have certain standard dimensions. It's rather expensive. Yeah, efficiency is also 90%. So you have an eye or your fork, or you can have thread ends put on your rope. Swaged end stops, yeah, usually on non-rotating ropes. These are put into certain sockets, so it has the advantage for your weaving system for mobile cranes that is much quicker to change ropes into blocks. And the efficiency is 90%, but normally we get 100% for this kind of stop or end stops. Very important end termination is sockets poured on. You have different kind of sockets, like you can see here, an open spelter socket with a closed spelter socket. Very important is that these sockets are reusable. So once the rope is discarded, you can use these sockets again, and it has an efficiency of 100%. How do you do this? You're gonna wire up the rope like this, yeah, the seizing wire. Then you're gonna open up the rope with the strands, and then every strands you're gonna open up till you have this brush full of wires. Then you need to degrease the brush, yeah, and then you put on the socket, you make your wire lock. We normally do it with wire lock. This is a powder and liquid which you mix up to a certain component, yeah, and you pour this component into the socket, and then you wait about 1 hour, yeah, and then the rope is fixed, the socket is fixed, and you can use it, yeah. These procedures are certificated by Lois. You can use it till 150 degrees Celsius, and look on the wire lock for it could be an expiration date. So it is limited to about 2 years or 3 years of in use. There is also sockets which can be poured on with fluid metal alloy. Some German manufacturers still do it. It has also efficiency for 100%, but take care, because you're gonna have to heat up the socket and also your wires till 340 degrees Celsius. This is not good for the wires. It is not good for your socket. So I prefer to do it with wire lock resin because yeah, it's more efficient, and also you can do it on the spot if needed. Same procedure with this special pier sockets poured on, let's say, and also for some certain application with end stops, which can be used on special sockets for DMAC, Manitowoc, Found, Leap Hair, for easy weaving, though for shortening wire rope, and it also gives you 90%. Right? Sometimes you have these special end stops for mobile cranes. Yeah, here you see all the different kinds of end stops, which can be switched on or which can be easily be poured on. And then in the end, we have the hand splice, sometimes used for a quick end termination. It's rather expensive, and the efficiency is only 80%. To end up, be careful with wire rope clips, because wire rope clips have to be efficient for 60 or 70%, depending on type of wire. If you use the number of clips which is prescribed for the diameter, which has the distances of 5 times the diameter between the different wire rope clips, which have to be used with a torque wrench, and which has to be checked after some time, because the rope will diminish in diameter, and then you have to check the torque again. Let's be honest, nobody does this procedure correctly, so therefore it is normally forbidden to use wire rope clips in permanent hoisting applications. So you can use it only for emergencies and for temporary cases, for example, for weaving. And then we end up with the wedge sock, yeah, wedge socket. That's for quick mounting. You see the right way to do it, yeah, and be careful for high performance non-rotating wire ropes. They sometimes need a special wedge socket. Yeah, efficiency is less than 80%, and be sure you always use wedge and socket from the same manufacturer. For pulling ropes inside your installation, you can use a welded chain link at the end of the rope for pulling, or you can fix it with a Chinese finger, a cable socket, or a woven cable grip. Efficiency is 10 to 30%, is just for, let's say, taking the rope into your application. These are the 5 chapters I wanted to explain to you. You can see all the expanded webinars. You can find the links on our websites. So thank you for your interest. I hope it was a little bit clear. And if not, you just go to the questions and answers, you tick it in, and let's see if we already have some questions.
Yeah, we have. I think it was really clear, because we only have 3 questions, but that's fine. And of course, what you mentioned, the recordings from the other sessions will be partly, well, also we shared within the email after this webinar. But Why is it not working? Q&A. There were 3 questions. What would be a consideration to select one of the more traditional layups?
The layups. What do you mean with the layer? The
layups is what?
The Lange lay or the ordinary layer one?
Perhaps M. Gremmen can explain his question in the chat. Otherwise, I will go to the next one. From Peter Zelstra. You named the steel wire rope a complex machine. It has no moving parts, however. Could you explain?
Well, if you bend a steel wire rope, you all have these different strands, and you have all in the strands these different wires, which move one upon another. So you need to have some lubrication between it. If you don't do it, you're going to have abrasion, you're going to have wear, and in the end, you're going to end up with wire breaks and with fatigue. So if you lubricate your rope, which was lubricated from the beginning, and the loop or the grease will end up in your grooves of sheaves or drums. So if it's gone, you're going to have a steel on steel contact into your wire rope. So you need to re-lubricate your rope again. How many times you have to do this? I only give advice, do it 2 or 3 times intensively on a whole lifetime, yeah? Because in the end, normally you end up with rope will be fatigued, but fatigue and wear will be a lot of lesser if you end up with greasing or oiling your rope again, depending on the oil or the grease you need and you apply, and also the application, you're going to have to 30% more longer lifetime. So it's a machine, and like all machines have to have some glue or have to have some oil or some grease. Just grease up your rope and it will last longer. And be careful, you don't only grease or oil your rope, you also grease your sheaves, the grooves of sheaves and the groove of drums, because there you also have steel to steel contact.
All right.
And sheaves and drums are more expensive to change than your rope. So I advise you to grease or oil your rope regularly. Yeah.
All right, we got an extra explanation on the question before about the layups. So the question was, what would be a consideration to select one of the more traditional layups? And the extra information is currently we use a 6-36 VS mostly, but you also explained a lot more traditional wire assembly before. You're able to?
Well, 6x36 is already a very flexible rope. It is often used, and it is available in large quantities. You have these ropes in left and in right, yeah. And if you have a sufficient lifetime and you have no wear, yeah, it's going to be a very, let's say, cheap rope, which will work. If you need to have a rope which is perhaps difficult to change, which is more complex in your reeving system, or which need to be in a lifetime double or triple, which has to be discarded more exactly so that you can predict when you need to have to change these ropes, you can end up with a high performance rope, 8-stranded, which is more flexible, with a special plastic infill, yeah, and which only need to be re-greased on the outside, because if you put grease on these high performance ropes, the grease won't get into the middle of the rope, because it can't get in the middle because you have a plastic layer there. So you only need to re-grease or oil the outer strands. And the outer strands will give you an exact idea when the rope has to be declassified and you don't have to take care of what is happening inside. Because if you have 6x36 Wellington seal, the rope on the outside will be discarded, but also the rope on the inside will also have discard criteria. But you don't see the wires broken on the inside. You never see it on the inside. So this special high performance ropes will give you the security you need. You only have to look at you only can see on the outside. And so take care. You never have to worry about what's happening inside. And if all the outer wires on the outside are broken, let's say, normally the strength of your intact wire rope core will do the job that you don't have crushing or accidents. So the security is much stronger. You're going to also have less wear in your sheaths, yeah, and on your drums, because the diameter of the rope will be more stable.
Right, great. 2 more questions, 5 minutes. About constructions, I have seen 6x19 SFC and 6x19 FC. I understand that the first one is seal and second one filler, but I also have seen 6x19 MFC.
That's
what does the M
M
mean?
is standard. That means you don't have, you have the old construction. Yeah, you have the 1 + 6 + 12. Altogether is this 19, and these are very cheap ropes. Why? Because if you make your rope, you have to combine different diameters of wires. That will be a more expensive rope. Yeah, and 6x19 M means standard. Yeah, you know, standard, which has these crossovers inside. Yeah? So if you want a rope which is more flexible, yeah, which will last longer, which has a thicker outer wire than the wires on the inside, then you need a seal. Yeah, and the filler is, let's say, the old type of 6x19 with 6 fillers ropes, which give you a more stable construction. So then we speak about 6x25, because you have 19 normally with 6 extra filling wires. But I advise to go into the webinar. We had the first webinar, and I can explain more in detail all these different constructions in standard, and also we widen up the more specific high performance wires. Yeah. Wire ropes, let's say, with the advantages, and I explain there all these things in detail.
Okay, final question. It says that the open and closed terminals with wire lock can be reused. How many times? Are there any discard criteria?
Yeah, that is an advantage for the ending up with sockets. Yeah, how many times? Well, normally you need to check every time the socket, if there are no problems with the socket. It can be done with Magnaflux, just to see if there are no wear into the socket. The only problem with these resin-filled sockets is you have to empty it up. You have to empty up the socket, and then you need to press the conus out of the socket. That's the only disadvantage you have against the alloy melting metal pouring, but you have the advantage that you don't need these high temperatures. And if you're going to need every time heating up the socket, this will also create problems. You're going to change the material from the socket, and anyhow, it will have, with this kind of temperature, also precautions for the wires, because if you're going to heat up the wires, it's also not good for the quality of the wire. Yeah. So normally there is no problem for reusing these sockets, and things are that you can send them back to the workshop. then going to be controlled if there are cracks into the socket, and if there is no problem, you can use the socket again. And how many times? There has been some reports that you can use it up to 100 or 150,000 hoisting cycles before you can just disqualify the, let's say, the peer sockets. So I've seen reports that till 150,000 movements or cycles is no problem with peer sockets. Yeah.
All right, this ends the questions and also our webinar. Thanks, Alain, for sharing all your knowledge and information. Thank you for participating. Hopefully somewhere later this week we will send out an email with the presentation slides, the recording, and also the links to the former 5 webinar recordings. If you have any questions on what topic soever, please go to your local company contact person and ask the question over there. So thanks again, and hope to see you next time.
Always at your service. Bye-bye.
Bye.